Hi guys, today we're going to learn how to solve compound inequalities. Inequalities are the same as equation, but equation two equal sides. Inequalities, the two sides are not equal to each other. Like when I say 5 greater than 2, that's an inequality. So what we're going to learn today is something called compound inequalities. Compound inequalities are two inequalities joined together using the word and or the word or. So for example, if I want to solve the inequality x greater or equal to -4 and x less than 3. To solve the inequality, you want to find the solution which work for both of them. When it's and, the solution has to work for both of them. So let's try to do this one. The first one, x is greater than -4. You don't have to do the whole number line like 0, 1, 2, 3, -1, -2. You can just put these two numbers here, -4 and 3, and on the number line. So -4, say this is the 0 in the middle. So x is greater than -4, so we are concerning about -4. Here is -4. Since it has equal, this means -4 itself is a solution. So we do it shaded like this. Greater, we go to the right. So the solution is going to be everything to the right of -4. So we shade everything to the right. So any point to the right of -4, including -4, is a solution for this part of the inequality. The two inequalities together with the word and, that's what we call compound inequality. So this one is a solution for x greater than -4. Now I'm going to do the solution of x less than 3 on another number line. So x less than 3. Notice this time there is no equal. So 3 should be somewhere to the right of 0. Say this is the 3. X less than 3. Since there is no equal here, when we do the circle around the 3, we don't include the 3. So we leave it open like this. Less than 3 means we're going to the left. So any point to the left of 3, but not including 3 itself, is a solution for the second inequality. Now we're looking for the solution of the two inequalities together, the compound inequality. I'm going to do over here the solution. So now we're looking for the numbers which satisfies both of them. Like we're looking for the common numbers in both inequalities. So over here it's 3 and it's open. All this is in both of them. So we go over here all the way to -4, but -4 is, so now this is the solution. When we do such problem, guys, you don't have to do the 3 lines like this. You can just do it in one line, as I'm going to show you now. I'm going to solve the same problem one more time, but now I'm going to show you the way you should do it so you don't spend too much time. I need x greater or equal to -4. So here is -4 because it has or equal, so we shade it in. We need x greater than -4, so we're going to go to the right. I'm not going to shade the whole line, I just know that I want to go to the right. Over here, x less than 3. So if this is 3, there is no equal, so it's open, then less, we go left. Then we shade everything in between and we are done. So you get the same answer like this, but you don't have to do all this work. Okay, guys? Example. When it's compound inequalities using the word and, we can just combine them together. Like you see this one, I can rewrite it like x in the middle, x less than 3, you put the big number on the right, greater, x greater or equal, you put the small number on the left. So this compound inequalities represent this one, but we put them in one inequality like this, we call it compound inequality. So over here, when this is written like that, this means it's two inequalities using the word and. So over here we have 3y minus 7 greater than 8 and the 3y minus 7 less or equal to 23. If you want to solve it, we solve it exactly as if we're solving an equation, but whatever we do to one of the three sides, we have to do it to the other two sides. And remember one more thing, when you solve inequalities, the only difference between solving an inequality and solving regular equation, if you divide by a negative number, the inequality has to reverse. Like if I divide each one of these three by -1, this should flip to the other side. Now let's do this one. We start from the middle. We want to get this y by itself. So what we do, we want to get rid of the -7. Over here we're subtracting 7. So we do the opposite operation and we add 7. So when you add 7, you have to add 7 to all of them. When you add or subtract, you don't change the inequality sign. You change the inequality sign only when you divide or multiply by a negative number. Now 8 plus 7 is 15, less, this is cancelled, bring down the 3y, 23 plus 7, that's going to be 30. Now we want to get the y by itself, so we divide by 3, we divide by 3, we divide by 3. Since we're dividing by a positive number, you don't need to switch this. So 15 divided by 3 is 5. 3 cancelled. Y less or equals 10. Now we just need to graph it. Number line here is 0. 5 should be over here. For example, 10 should be over here. Y greater than 5, there is no equal here, so the 5 is going to be circled and we are going to leave it open. Less or equal to 10, so the 10 has to be circled, meaning the 10 itself is part of the solution, but 5 itself is not a part of the solution. You have to be greater than 5, even 5.001, that's a solution, but 5 itself is not a solution. Greater than 5, we go to the right. Less than 10, we go to the left. So that's the solution. Now you need to practice these two problems. So pause the video and try to do the first one, then come back and check if you did it right or wrong. We start, guys, from the middle. Over here we need to get y by itself, so we need to get rid of the 8 first. So we subtract 8 because the 8 is addition, so we do the opposite, subtraction. So we subtract 8, subtract 8, subtract 8. Bring these down same way as they are, don't change them. The -8 is cancelled, so in the middle we have 4y. -12 minus 8, that's going to be -20. 32 minus 8, that's gonna be 24. Now we want to get the y by itself, so we need to divide by 4. Always you leave the division for the last. So -20 divided by 4 is -5. -5 less or equal to y, less or equal to 6. So this is compound inequality, guys. From the beginning has the word end. Like if you want to read it, it's going to be 4y plus 8 greater or equal to -12 and 4y plus 8 less or equal to 32. Now you just need to graph this one. So we graph it. We need only two numbers, the -5 and the 6. -5 should be on the left, 6 should be on the right. We have equal here. Less or equal, or greater or equal, so we shaded, less than 6, you go this side, greater than -5, this side. Always when it's and, the solution is going to be between two numbers, everything between two numbers. I hope you got it right, guys. Now the second problem, we want to, same thing, of course, pause, try to solve it, come back. Anyway, we need to get this x by itself. Don't worry about the 3. The 3 is multiplied. Leave the multiplication for the end. Always start with addition or subtraction. This is subtraction, so we add 2. So you have to add 2 to all sides. The negative 2 is cancelled. You bring down the 3x. Negative 5 plus 2, that's going to be negative 3. Over here greater, there is no equal. Negative 14 plus 2, that's going to be negative 12. Now 3 times x, so now we do the division. Since I'm dividing by positive number, we don't change these. Negative 3 divided by 3 is negative 1, greater or equal x greater negative 4. So now x is less than negative 1 and greater than negative 4. Now we want to graph the solution. You draw a number line. Which number do you think is going to be on the left? The negative 1 or the negative 4? The negative 4, that's right, because negative 4 is smaller. We go 0, negative 1, negative 2, negative 3, and so on. Over here we have equal. So the negative 1 is going to be shaded. Over here greater than negative 4. So negative 4 is not shaded, open. And then we shade everything in between. Remember, greater you go to the right. So x greater than negative 4, you go to the right. X less or equal to negative 1, you go to the left. So that's the solution. Now guys, we are going to do the OR compound inequality. The other one we just did is AND. This one is going to look like this. X greater or equal to 5 or x less than negative 3. As you can see, this you cannot combine them in one inequality because you can't be greater than 5 and at the same time you are less than negative 5. So this one, when we solve it, actually we draw a number line and we put these two numbers on the number line, the smallest number always to the left and the higher number is to the right. So 5 is going to be over here and negative 3 is going to be over here. X greater or equal to 5. Since it has or equal, we shade this in, means 5 itself is a solution. Greater than 5, you go to the right. X less than negative 3, there is no equal, so you make it open, meaning negative 3 itself is not a solution. Then we go to the left, because less. Now you can't find an answer which is going to be solution for both. It's either solution for this or the other one. So as long as the number is a solution for one of the two inequalities, it's solution for the inequality. And let's do example, solve. That's example 1. Solve. K plus 6 less than negative 4 or 3k greater or equal to 14. So we solve each one of them and then we draw both of them on a number line, and when it's OR, the solution should look like this. Part of the solution going to the right, part of the solution is going to the left, and there is no common in between. In between is going to be no solution here. So if you want to solve this one, mean you want to get the k by itself, so you want to get rid of this positive 6. So we subtract 6, we subtract 6. Then bring down the k, bring down the less than, negative 10. So this one is solved. Over here, there is no addition, so we have to do the multiplication, divide by 3, divide by 3. Since you're dividing by a positive number, this sign here of the inequality in the middle is not going to change. So the 3 is cancelled. K is greater or equal than 14 over 3. By the way, 3 goes into 14 4 times, so this is like 4 point something. So when we draw the number line, we just put this 14 over 3 a little bit to the right of the number 4, because 3 goes into 14 4 times. So now we're going to represent the solution on the number line. Negative should be on the left. Say this is the negative 10. This is positive. If this number here is 4, then this should be the 14 over 3. Greater or equal, so this is shaded, means this number itself is a solution. Negative 10, there is no equal, so it's open. Greater than this number, you go to the right. Less than this number, you go to the left. So as you can see, when it's or, you go outside, nothing in between. When it's and, it's going to be whatever in between.